Hello. In my last video, I discussed the four major IDE components that each IDE must have: build system, code analysis, project management, and user interface. So, in this video, I will make a simple command line build system. For now, it will be able to accept a simple XML file containing project information and build an executable from it. But before coding like a madman, it is a good idea to plan a rough sketch of the code. So let's do that first. So here's the plan. I want the build system to be a standalone component. It should be able to work independently of the IDE, much like MS Build. So there will be a single namespace that will encapsulate all of its code. I have decided to call my build system Leo. So let's call this namespace Leo as well. Inside this namespace, there will be multiple classes, each one for a specific component of the build system. The build system itself will be a simple class that will be responsible for loading project files and invoking the compiler interface. The compiler and linker interface will be abstracted into a compiler class. This class will accept project information from the build system and call appropriate compiler and linker. To make things more modular, each compiler interface such as MinGW, CLang, and MSVC will be abstracted into separate toolchain classes. There will be a toolchain base class that will contain components common to all compilers and linkers, something like a dummy compiler interface. All other toolchain classes will inherit from this base class. This abstraction will aid in adding support for more compilers in the future. The compiler class will have objects of all available toolchain classes, and the build system class will have an object of the compiler class. The build system will set the required toolchain in that compiler class object. There will be an object of this build system class inside the main function. In this way, we will obtain a console executable that can be used as our build system. We will also be able to use the same build system class in Leo namespace within the IDE. Now, with the plan ready, let's write some code. Let me grab my computer. I am currently using Linux as my main development platform. Here, I have Sublime Text 4 ready and configured. In my last video, I said that I will be using base Sublime Text, but I thought it will be helpful to install some plugins. So, I have installed the Terminus package, which will enable terminal support from within Sublime Text. I have also installed A-file icons for aesthetic reasons. Here on the left, you can see the initial project structure. Let's first create two directories, include and src. Include directory will contain all include files, and src directory will contain all source files. Inside the include directory, I'll create the first file. This file will contain the compiler and toolchain classes. Inside the Leo namespace, I will first create the toolchain base class. This class will encapsulate data common to all toolchains such as source files, header files, compiler options, and linker options. Since this is a basic build system, for now it will only keep track of source files, header files, compiler and linker flags, preprocessor definitions, compiler and linker include directories, and linker libraries. This base class will also serve as a default dummy toolchain, hence the name dummy compiler. Next, it will have public member functions for setting sources, compiler options, and linker options. Next up, there will be 3 virtual functions for setting up compiler state, compiling source files, and linking the final executable. All of these will be virtual functions so that they can be overridden by children of this base class. This will allow all derived toolchain classes to handle their functions independently. The compile function here will return a list of compiled object files in the form of a vector of strings. This list will be passed to the link function that will then link the final executable. Now, let's create a class for MinGW toolchain, derived from the toolchain base class. Next, I'll create a compiler class that will be used by the build system to interact with all toolchain classes. This will contain objects of toolchain classes as private member variables. An enumerator will be used to select the desired toolchain. I'll just copy these functions into the compiler class. And this function will set the active toolchain. By default, the dummy compiler will be active. Now, let's implement these functions. For that, I'll create a new file, compiler.cpp, in src directory. Let's first implement functions of toolchain base class. To build programs, this build system will create an obj directory to store compiled object files and a bin directory to store final executable. So, in the setup state function, we will check if these directories exist. If they don't, then we create them. After some time, we will need to call the compiler and linker to build programs. Calling another program from within one program requires the assistance of system calls. On Linux, it is achieved by calling fork system call that creates a copy of current process. After that, a call to one of the exec functions replaces this copied process with desired program. On Windows, the create process system call does this job. So let's abstract this into a separate function that will dispatch appropriate system call on each platform. I'll create a separate file for utility functions like this. In this file, there will be a utils namespace that will host common utility functions. Let's implement the wrapper function within this namespace. It will take the program name and a constant reference to a vector of strings containing arguments to the program. I will be using exec_vp function to start external program. Since this function takes an array of character pointers as argument, we first have to convert this vector of strings into an array of character pointers. Now let's fork this process and call exec_vp. Now let's implement the compile function. In this function, I'll first create a vector of strings that will be passed to the compiler and the vector of strings containing a list of compiled object files. Since this is a dummy toolchain, it will not actually compile any file, but will act as if it compiled them. In the link function too, I'll first create a vector of strings that will be passed to the linker. Again, this is dummy toolchain, so it will not link anything. Now let's implement the functions of min_gw toolchain. To do that, I can simply copy the ones from toolchain base class and modify them a little. Now let's implement the compiler class. Now let's create a new file to store build system class. Next, a new file for implementation of build system class. In here, we will need to parse the project file, which will be in XML format. To do that, I will be using TinyXML library. Let's clone it into our project under third-party directory. Now let's copy relevant files into ext directory. Now, before we load our project file, we need to verify its structure. So let's do that first. Next, we need to design an XML structure that will hold project information. So let's create a simple project file. There we go. We now have our project file's XML structure ready to parse. With the project structure verified, let's load the project. Before starting the build system will display build information. So let's implement that first. Time to clean up and fix a few things. Now, time for the main function. Now let's create the CMake list text file and set up a simple CMake project. We've got some errors here, so let's fix them. There we go. Our build system is ready to run. Now, as a test of this build system, let's build this build system with itself. Oh, it got stuck. Well, it was a simple parsing error. After fixing that, it's ready to run. Let's run it in a separate shell. There we go. It started fine, parsed the project file and displayed build information. But it hasn't built anything yet, because the build system is currently using the dummy toolchain. Let's change it to MinGW. Now it is actually compiling source files. Here we have all the object files. And there's the final executable. Perfect. So that's it for this video. I built a simple C++ build system. Currently, it lacks many features of a proper build system. As an example, it compiles every source file each time it is invoked. This is not optimal, as only the files that have changed should be compiled. So, it would be nice to have some way of tracking changes in files. Moreover, it has no option to specify build directory or build variants like debug and release. All these will be implemented in a later video. The source code is available on GitHub. Check it out from the link in the description, and see you in the next video.